Okay, so it's already week 5. We're like halfway through the quarter. Can you believe it? Well, you guys probably can. Okay, I posted I posted last year's midterm. So the midterm I gave to the class last year, that's available online. You can take a look at that as to get a sense of what will be asked. Of course, the questions will be different. And my recommendation is to actually try to print it out and try to answer the questions with pen and paper, okay? Because that is how you will have to answer the questions on Friday, okay? So on Friday we have our midterm exam, and you will answer with pen and paper or pencil and paper. You do not have your computer, you don't have notes, you don't have books or anything like that. So, do your best. And then, if you want to verify your answers, all you do is you just, all you do is you just type in the code into R and see what R outputs, because that's effectively what how the questions work, okay? So for example, it starts off and I say, f is a function of y, where y plus 1 gets superassigned to y, and then we multiply 2 times x, okay? And in our global environment, we say x is 3 and y is 5, and I say f of x. So then, what will this thing return? Yeah, so when you plug in 3 into here, and then, so 3 goes in as y, and then it gets to this thing, and this is the value that it's going to return, which is 2 times x, but there's no x inside the function, so it's going to climb the scope and find the 3 assigned to x, and it's going to return 6, okay? And what will y return if back in the global environment? It will return 4, because you've said a function of x and you've taken the argument 3. 3 plus 1 gets assigned to, in the global environment, to the value y, all right? So anyway, try this out, see if you can answer all of these questions by hand yourself, and you can expect the midterm to be about in similar length, something around there. It's going to be a bunch of probably poorly written code, like not exhibiting best practices, and you have to be able to understand how R is going to work. Because that's what it comes down to when you're debugging programs in R. You have code that doesn't work, or code that's doing something that you are not expecting, and you have to be able to read through the lines and figure out why it's behaving that way, okay? It's not that, of course, if you have well-written code that everybody understands, sure, it makes sense and everybody can follow. What separates, I think, people who are proficient and from others are, can they read and understand how R is going to behave in a certain situation. I've also posted the template for homework number 3. Okay, homework number 3 covers the use of dplyr and rvest, and there's a very small object-oriented lesson in there as well. And then regular expressions, which will be the subject of today's lecture, okay? And so as far as content on Friday, it will cover up through today's stuff, which is regular expressions, okay? And then on Wednesday, we'll talk about other stuff, but that's not going to be on the midterm exam. And so that's here, and the homework is due 1 week from Wednesday, so you have like 9 days to get it done. I think that should be enough time. Okay. Any logistical questions before we begin today's lecture content? All right, everybody's happy? Maybe? Okay, well, we'll take a look. So today's lesson is on text processing and regular expressions. This is, I think, such a cool topic. As cool as text processing can be. And this is not natural language processing. We're not trying to pull meanings from words, which is also a really cool topic, but beyond the scope of our course. This is just handling characters. And basically our most powerful tool is regular expressions. So sometimes you go to Microsoft Word and you decide, you know what, I need to like search and replace, right? And you say like, we're going to search for every time it says Jason, and we're going to replace that with Kimberly or something like that, right? And I don't know, maybe it's just like some generic form letter or story or something, and you're just going to do something. So I think we're familiar with the idea of kind of searching and replacing, and that's basically what regular expressions do. We just search, and then we can either manipulate whatever we find or whatnot. So, but how regular expressions differ from what you do in Microsoft Word is that you can specify kind of ranges of characters. So you can say, we want to find anything that looks like Jason written in all caps or lowercase or something like that. You can say, I want you to find anything that looks like a phone number. And a phone number comes in a set of three digits, either with parentheses or not, and then a dash, and then another set of 3 digits, and then a parentheses or some kind of separator, and then 4 digits, right? Or you say, I need to find, we had named files, that were in the form of kind of a date plus a person's name. And so we want to find all of these files that have this format, and regular expressions allow you to express these flexible statements, okay? And R has some built-in tools called grep and things like that. These are based on tools from the bash shell. I think string R, this is a package, again, developed by Hadley Wickham, probably even extends this a little bit further and makes it a little even better. And so you're going to want to install this package into R, load it up with library, and then you can click this vignette. So anytime you load up a new package in R, you should see if there's a vignette. And a vignette is kind of often like a small tutorial or a small set of samples of what kind of examples that you can do with the package. Okay, so for example, you can match white space and things of that nature. The functions that we have are detect, locate, extract, match, and split. And I would say probably the ones we use the most will be match and extract, but these other ones are also useful, okay? Detect just returns a true or false. It says if this pattern that you have written out is found inside the string, so there's 2 arguments, all of these functions take in 2 arguments. One is a string with all the character data that you are going to search through. So this could be, when it says string here, this could be like multiple paragraphs, right? It could be hundreds of lines of text. And then the pattern is whatever thing that it is that you are looking for. Okay, detect just says, is that pattern inside there, yes or no, true or false? Okay, locate will say, this pattern is located here at starting at the 58th character, or 1472nd character, or something like that, okay? Extract says, I found it, and this is what I found, okay? And if your pattern is just a literal match, like the name Jason, then string extract will not be interesting because it's just going to extract Jason, right? But then if you say, I want you to search for something that looks like a phone number, extract will pull out the thing that resembles a phone number. String match allows you to form capture groups, okay? And so with a pattern, you can say, this is the entire thing that I am looking for, but I want you to separate out these different pieces. So for example, maybe you're reading a news article, and sometimes they'll list a stock name and its current price or something like that. And so you might want to say, I want you to extract out anything that looks like this, which is usually, a stock name will usually be like capital letters, right? Followed by, maybe there's a colon and a number. And you tell the regular expression, I need this thing that has capital letters, a colon, and a number, and I want you to separate out the group of capital letters, that's going to be the stock symbol, and then I want you to separate out the price, which is going to be the number, or something like that. Yeah, I don't know. Or perhaps you're looking for something that looks like a web URL, right? And you want to separate out, the top level domain. So maybe versus kind of the rest of the path. So maybe something's located on the UCLA website. Maybe you just want to pull out the, I don't know, there's like recreation.ucla.edu, and then there's like stats.ucla.edu, and, political science, or, all these things. And maybe you want to just pull out that first group. You can express that with a capture group. Okay? And string split does something similar, and it just splits up the string into pieces based on kind of the pattern that you give it. Okay. And a lot of these things, there's also string detect all, locate all, extract all, and match all, and things like that, which will, locate will just return the first one, and then string locate all will return the position if it finds multiple matches. So if you're looking for the string JSON, it'll say like, oh, we found it starting at character 58. If you have string locate all, it will say, oh, we found it at character 58, character 272, character 584, so on and so forth. It will locate all of them, things like that. All right, so let's try this out. Here's a silly comic about regular expressions. This is from XKCD, which if you don't read that webcomic regularly, you should all start. Well, anyway, all right. We don't need to spend time on that. Okay, so here I am giving it. So I have a few examples that use the quick brown fox jumps over the lazy dog, but this one is the text is separated into separate words, and so this is a vector of 1, 2, 3, 4, 5, 6, 9 words, and we are going to see, do you detect the phrase quick, Q-U-I-C-K, in any of these 9 strings, okay? And it says, I do not detect it in the first, I do detect it in the second, but not in any of the other ones. So it says false, true, false, 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 okay? Then we say, do you detect the character O? All right, and it says, no, no, I have detected it in the string brown. I have detected it in the string fox. I have not detected it in jumps. I have detected it in over, and et cetera, et cetera, et cetera. Okay. What about, do you detect the string characters R-O-W in that exact order? And it says, no, for everything except for the word brown. And it says, yes, I have found that thing. Okay, that's simple enough. So that's the literal matching. The power of regular expressions comes from its use of meta characters, okay? And these are kind of all of these special things, and we will talk about each one of these meta characters, okay? And so for example, and the thing is if you use one of these meta characters in your pattern, and you say like, I want you to search for the square brace, okay? Square bracket right here. If you just type in the square bracket, R is going to say, it's going to assume that you are talking about the meta character meaning and not the literal square bracket, okay? And so if you want to match the literal square bracket, you have to escape it using a backslash, okay? Unfortunately, the backslash itself is a meta character, so you have to further escape that. So at least in R, not in all languages. So in other languages, it's a single backslash square bracket, but in R, because the backslash is an escape character, you have to do double backslash square bracket, and it will say, I have found the literal square bracket in this string that says ABC square bracket DEF, okay? Whereas over here, it says, there's an error here, you're missing the closing brace because it's seeing this as a meta character. Does that kind of make sense? All right, and then yeah, double backslash because backslash is an escape character. Okay, so what kind of patterns can you match? One is patterns based on anchors or location, okay? So you can say, I want you to find this thing, but only if the string starts with this thing, or only if the thing ends, the string ends with this pattern that I'm looking for, right? So you want to search for all sentences that begin with, I don't know, Einstein or something, okay? Then you say, but you don't care if the word Einstein shows up in the middle of the sentence. You say, you place this anchor here and it said either the caret or the /a, which will need to be a double /a, and then it will only search when the string starts with that, okay? There's also word boundaries, okay? And we have word boundary, which is /b, and then non-word boundary, which will be /big B, okay? You're gonna see a lot of kind of this recurring theme or pattern in that B represents word boundary, D represents digit and stuff like that, and the little lowercase letter represents that thing, and the capital case letter represents not that thing, okay? Just so you don't have to say like not boundary, you just say capital B for not a boundary. Okay, so little b is for the boundary and capital B is for not a boundary. Okay, so here we're going to use the function string replace, and it says replace if you find this pattern, which is anchored at the beginning, only at the beginning of the string, capital THE, and if you find that, replace it with a dash, okay? And now this time my text is a single string. It's not 9 different strings or a vector of strings. It's one single string that says the quick brown fox jumps over the lazy dog. Okay, and so R says, yes, I have found the string begins with capital THE, and I will replace that with a dash. Okay, here it says replace this if you find at the beginning of the string, the caret, DOG, okay? And it says, well, at the beginning of the string, I do not find DOG, so it doesn't replace anything. It just returns back the entire string. Even though we have DOG here, this is not at the beginning of the string, so it doesn't work, okay? Same thing with here. $ represents the end of the string. There is no match for THE end of the string, so that returns back the entire thing without making a replacement. Whereas over here, I've got dog with the end of the string, and that will return a match. Okay. If I had a space after dog, it's not going to work because it would see that dog is not at the end of the string because there's a space after it. Similarly, if you didn't want to use carets or $, or for some reason, you can also use /A or /Z for the beginning or the end. Here we're going to look at boundaries. So /b means you need to have a word boundary. Okay, a word boundary generally means a space or a punctuation to indicate that this is the start and end of a word, right? So when you read sentences, your eyes look at spaces and say, oh, these are separate words, right? So you can differentiate between the word worthless, one word where there's no space in between them, and worth space less, and those have significantly different meanings, right? And thus we have word boundaries, usually spaces, okay? And so here it basically says you need to have a word boundary before JUMPS, and it needs to end with a word boundary. So basically, you need to find the word jumps, and that needs to be the entire word. If it's like, I don't know, jump space or something, I don't know if that's like, or jumpsuit, okay? This would not match because jumpsuit, even if it's one word and has the letters JUMPS, because it's followed by a U and not a word boundary, it will not match jumpsuit, okay? But here it matches here. Over here, I've got /B jump /B, and again, even though there is JUMP, because there is the S and not a word boundary, it does not match. here I've got UMP with capital B's, meaning the UMP has to be in the middle of the word and not, it cannot border the end. So if we had the word umpire, this would not work because UMP would be at the beginning of the word, bordering a word boundary, and we're saying we don't want that. Okay. And then similarly, we've got, if I did it with the J, now this does not match. I think I've got a few more examples of in-class regex exercises. I think these are all the ones from, let me see. So here I've just created the string, the quick brown fox jumps over the lazy dog, and then I've got UMP as its own word. And so the question is, will this string, will this pattern, slash capital B, UMP slash capital B, what will that match? Will it match anything? And what will it match or replace? So this would match the UMP and the word jumps, right? So if I run that, oops, I have to load up stringer. Okay. So it matches the UMP and the word jumps, okay? What about, again, taking a look at our text again. What if I use this one with little b, slash little b, slash UMP slash little b, okay? Will this match anything? Will it return the entire string? Or will it replace something? What will it match? So this, the word UMP at the very end qualifies because there's a space before it indicating there is a word boundary which matches the little b, slash little b, and it's at the end of the string which also counts as a word boundary. So it matches the UMP at the end of the string and replaces that. Okay. If I just run text UMP and I do a replace all, it will replace both the UMP in jumps and the UMP as a word all by itself. Okay, what about this one? Slash big B, so non-word boundary JUMP slash big B. What will this match? This one does not match anything, right? Okay, how would I get this to match? I would have to put in a little b here to indicate that JUMP should begin at the beginning of the formal word boundary there. So if I put a big B, it's not going to match, but a little b will. Right? Because this is the word jump, there's a word boundary right before it. Okay. So you can kind of mix up these things. Are these examples all right? I've got some people nodding, and then I've got blank stares from a lot of people. Good. We good? Okay. Not the greatest enthusiasm here, but we'll continue on. Okay. We can specify classes of characters. Okay. So slash little s is for white space. Okay. We've got white space. And then slash big S is for anything that's not white space, right? Okay, so white space would be things like, well, spaces. And there's things that, breaking spaces and non-breaking spaces. And I'm not sure if you guys are familiar with non-breaking spaces because it looks like a space. But here, let me just kind of illustrate what a non-breaking space looks like. So, so we can write a sentence like, We live in the city of Los Angeles, okay? And if I say I live in the city of Los Angeles, it splits the word LOS and Angeles, right? Because there's a space here. And so when you're typing your Word document, Word says, oh, these are separate things, right? And if you want to keep Los Angeles together, you could put in an underscore here, but then you're like, well, that's not actually what I want. I want a space in there, okay? So you can actually hit, which one is it? How do I insert is it Control-Shift space? One of these, there's a command character. Yes, okay. So these are regular old spaces, but if you hit Control-Shift space on your keyboard, this puts a space in between Los and Angeles, but it says this is a non-breaking space. It's basically the same thing as using an underscore, but it looks like a space. So this is a regular space. Control-Shift space puts a non-breaking space, which means I can continue to write, and then as soon as this reaches the end, rather than splitting Los and putting Angeles on the next line, it moves everything together, okay? So those are non-breaking spaces. It looks like a space, but it's treated as if it were an underscore to keep the word together, okay? Meaning do not form a break at the end of the line between the words Los Angeles, because sometimes there's things like that where you don't want to split the words apart. Okay, so anyway, a /s will match both breaking and non-breaking spaces there. Okay, capital S, anything that's not white space. Little d for digits, capital D for non-digits. Little w for word characters. Word characters are considered to be anything in the alphabet plus the digits 0 through 9 or underscores. Okay, so basically when you create a username, and nobody creates usernames anymore, but back in the day, you had to create usernames to join a website. And if your regular name was taken, you would often have to do like Miles Chen underscore 123 or something, your favorite set of numbers. And basically /w would match all of those things. And then /W is anything that's not one of those. Okay, we have the very dangerous but very useful dot. Okay, the dot means any character except a new line character. So this will like match anything and everything. And then we can also specify ranges. We can say, I want to match an A or a B or a C. Okay, this is not match the pattern ABC. It's match either an A, either a B, or a C. And then you put in a caret there, and it's like, match anything other than the characters A, B, or C, right? You want longer ranges, you can do A through Q, or whatever, or you can specify digits and say, I want anything in this range 0 through 7. So these slides are a lot to take in, but they form a lot of the heart of what's happening, and we will explore some examples, okay? So we've got space, white space, digits, word characters, letters, any character, digits, ranges, right? So you put ranges in square brackets. And then we have quantifiers, okay? I don't know if you can see. A star means you want to match this character 0 or more times. Okay, match this character 0 or more times, meaning you're totally fine if this thing doesn't exist, or one or more of these, okay, or more. The plus means this thing has to be matched at least 1 or more times. Okay, and then a question mark means match this 0 or 1 times. So is it there or is it not there? And if it's there, I don't want more than 1. Okay. And then curly braces specify exactly how many you want. I need exactly 3 of these. So for example, you're looking for something that looks like a year. You can say, I want it to start with 2, 0, and then followed by 2 digits, okay? Or I want to start with 1, 9 followed by 2 digits, okay? You don't want something that says 20,000 leagues under the sea. You don't want to match that. You want to match, 2001, 2025, whatever, okay? And then you can say 3 or more, 3, 4, or 5. You can specify a range here using curly braces. So these are quantifiers. Okay, let's try a few examples here. Okay, so here I've got, is this large enough? Are you guys able to see this? No, okay. You should have said that earlier. Okay, I don't know if this is better. I'll move the console to the right. And then, let's see. Make our text bigger. So you got to balance being able to fit. Okay, so this is our text. We want this text. Okay. Here we're going to just replace the letter O with a dash, and so this will just replace the first instance. If I want to replace all of them, I use replace all, and this will replace all O's with a dash. Okay, this is O followed by /little w. What does that mean? /w is word character. So this says match the pattern E, O followed by word character. And replace that with a dash. So what it's going to do, so over here we replaced all the O's with a dash. So we've got brown, fox, over, dog. All of the O's there got replaced. What this will replace will match the O followed by the character after it. So it will replace the OW, the OX, the OV, and the OG. So there we go, okay? So now it looks like we're swearing or something, but that's what we have, okay? Let's take a look at the original text, okay? And then I got E/W, okay? So this will replace anything with the letter E followed by a word character. So what will this replace? Okay, so the only thing that matches is the ER in over, okay? Because the E in the does not match because it's not followed by a word character. So over here we get the ER in over gets replaced, but not the E in the. Does that make sense? Because we've got a word character. Here I've got E followed by a non-word character. So what will this match? It will match the E in the. Okay? So it matches the E in the and actually the space after it. Okay? The E and the E followed by the space gets replaced with a dash. The ER does not. Okay? Here I've got E followed by digit. E followed by digit, replace that with a dash. What does this match? It matches nothing, right? It just returns back the string as it is. E followed by capital D, /capital D, so non-digit. What will this match? It'll match the ER, and I believe it'll match the E space. Well, let's see. Okay, so we've got, it matched the ER and then the E space, because these are E followed by a non-digit character. Okay, I got E followed by a /little s. Oh, and I'm sorry, I forgot there's the word the up at the beginning. Okay? E followed by slash little s means E followed by white space, so it will replace the E's in the. In both of the thes. Okay, so we've got the and then the E's in those because those are followed by spaces. E followed by a big S is anything that's non-white space, so it'll replace the E in over. The E and the R in over. I know it's a lot, okay? It's a lot. It's really powerful stuff, okay? Meaning you need to find like a bunch of different word patterns of characters. You can generally probably come up with something with a regular expression that will do this. Okay, here, so again, let's take a look at the text. So I've got the quick brown fox jumps over the lazy dog, ump, and here I say O followed by X or G. Replace that with a dash. O followed by X or G. So that's going to replace the OX in fox and the OG in dog, but it will not replace the OV in over. The quick brown F jumps over the lazy D, okay? That's what we have. On the other hand, I put square bracket caret xg, meaning O followed by anything other than an X or G. So what will this replace? So it will leave fox and dog intact, but then it will replace the OW in brown and the OV in over. Okay, so that's what we have. The OW in brown and the OV in over get replaced. E followed by anything other than an R. Okay, so it replaces the E in the and E in lazy. E followed by R just replaces the ER in over. Okay, here's something interesting. I put in THE, replace THE with a dash, okay? But the THE is in a square bracket, and I said string replace all. So what will this do? This will replace anytime it sees either the letter T, the letter H, or the letter E, it will replace each one of those with a dash. So here I've got THE gets replaced here, the E in over, and then all THE in this word the get replaced. This capital T does not get replaced. If I took away the underscore all here and I ran it, what will it do? It will replace only the first H, okay? Because it only replaces the first. So all will do all of them. Without the underscore all, it will just do the first, okay? This line, THE here, is exactly the same as writing this because we are EHT. It doesn't matter the order in which you run this. It's going to return the same results because it just sees this as a, quote, class of character or like anything in this grouping. Yes?
Oh, why did it not replace the first E as well?
For when I did string replace without the underscore all?
Yes.
Okay, so string replace will say search for this pattern. Means we are looking for one character that matches T, H, or E. Find the first one and replace that one only. So it finds the H and it says, that matches this entire thing, T, H, or E. And it says, I found an H, okay? And therefore, it has fulfilled its job and it's not going to continue because it's not looking for like one of the T, one of the H, and one of the E. It just says one match of this pattern. This pattern says one character, either T, either H, or E. And so this fulfills it and it's done. Okay. Here I can throw an EH and T with a capital T in there also, and then it will replace the capital T at the beginning of the sentence as well. String replace all A through Y. So what is this going to replace? What will be left? The T and a Z, right? The capital T and the Z. And everything else got replaced with dashes. It's like the worst game of Hangman. All right, and then here, O followed by word boundary. I'm sorry, O followed by word character. So this will be just the OV and over. I'm sorry, and the OW and brown and the OX and fox and the OG and dog. Okay. Over here, I've got /W plus. Plus means one or more. So right here, it replaced OW in brown, but the W plus means O followed by any word characters. And so it will replace the O and then the W and the N with a single dash. Okay? And then for over, it will see the O followed by VER, and those all count as word characters, one or more, and it will replace all of them with a single dash because they all count as matching this pattern. Okay? A single instance of that pattern. So I've got BR dash, F dash, and then the entire word over just gets replaced with a dash. It's not multiple dashes, it's just one dash because that entire string, OVER, counts as a single match of O/W plus. Yes, question?
For the A through Y thing, if you wanted to include the capital T inside that A through Y, how do you do that?
Just like this.
Oh.
And then, so if you wanted to do just a range here, you can do capital A through T and so on and so forth like that as well. All right, let's, here I think I changed up, I added the word whammo to the end, okay, to just kind of mess around with how this might work. So, so I got the quick brown fox jumps over the lazy dog and then UMP and whammo. And here we'll run the same thing, O and W plus, okay? W plus means the O needs to be followed by a word character and the plus means one or more. So when I run this, it replaces everything as it did before when I did the W plus, but it does not match the O in whammo because whammo ends with an O and there's no word characters after it. So that doesn't qualify. Over here, I've got O/W star. W star means 0 or more. So this will match the O in whammo, even though it's not followed by any word characters because we just said 0 or more word characters. And so the O in whammo gets replaced. And O dot plus, the dot means any character, one or more. Okay? So what happens here is it gets to the quick brown fox, and then as soon as it sees the O in brown, it just says, oh, any character, one or more, everything, owl fox jumps over the lazy dog, UMP whammo, all of that qualifies. We're going to replace all of that with a single dash. Okay, so the dot is potentially very dangerous, right? Because it can just wipe everything out, right? I think there's a story about how Toy Story 2, the movie, which is now super old, almost got, well, it did get completely deleted because somebody accidentally used dot star and like removed all the files there. But it was all saved because one woman who was working on maternity leave had made a copy of the movie onto her hard drive and took it home to work at home, and anyway, it was fine. Okay. You can look it up, how Toy Story 2 almost got deleted. All right, oh, and then /W question mark is word characters 0 or 1, okay? So this will replace the OW and brown, but not the N because it's 0 or 1. It will do 1 if it can do 1, and if it can't do 1, then it'll do the 0. So it replaces the O and WAML as well. I've got more quantifiers here. In the interest of time, I'm gonna just let you explore kind of these examples on your own, okay? Let me keep talking here. There's this concept of greedy matching, okay? So if you use the star, it's gonna do like everything it can do, right? Greedy will try to match as much as it can. So it looks at this thing and says, okay, we've got to start with this, and then it's got to start with this opening div tag, and then dot star means like any character 0 or more, and then the pattern just needs to end with a /div. This means when it looks at this thing and it sees a closing /div here and another closing /div here, it's going to get as much as it possibly can that counts as a match. You put in the question mark, this makes it ungreedy, and it will try to make the match as short as possible here by ending at the first div tag. So the difference is that this will return, if you had more text here, it will return everything until it gets to the closing div tag, and over here, as soon as it can end the matching, it finishes there. Okay. If inside the pattern that you are matching you put in parentheses, then R will extract the entire pattern, but also separate out the piece that you are matching. Okay. So here we say match the string, the pattern ABCD, and then we put parentheses around BC. Okay. So when we run this, when you do extract, it pulls out ABCD. When you do match, it pulls out ABCD, but it says, you know what? I pulled out that little piece BC just like you asked, and it puts it out over here. And so if you had abstract characters over here, this will pull out whatever matches. So for example, we have a bunch of phone numbers here, and I've specified something that looks kind of like a phone number pattern. Okay, and I know this is a lot to take in right now, so just in your own time, kind of parse it out yourself. And what this does is when we run string match, it takes the phone number, and then it says, you know what, you specified these patterns. One was kind of for the first 3 digits, which will serve as an area code, and it pulls that out. Then it pulls out the next part for kind of like the prefix and the suffix and all of that in the phone numbers. And so string match allows you to take the entire string thing that matches the pattern, and then it pulls out and separates out different pieces there. Okay. I strongly encourage you, when you're playing around with regular expressions, to go to this website called regexer, and here you can type in kind of different patterns, and it will show you in real time what it matches. Okay. Okay, we'll end here for today. We'll see you guys on Wednesday.
Hi, Professor.